Test, 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 test. Welcome to another video in the Metric Math Water and Wastewater series. This video is going to cover how to find the slope of a line when the rise and the run are provided. It also will show how to manipulate this formula around to solve for any unknown if two of the three variables are given. Finding the rise, run, or slope of a line. When we take a look at any sewer line installation, one of the most important things that you have to be aware of is what is the gradual slope of that particular line. How much does it go up? How much does it go down over a given distance? So that is the slope of the line. So that is the slope of the line. Now, when would you need to find the slope? Well, if you have two manholes, for example, that are a certain distance apart, you have to know what's the minimum slope or what's the maximum slope between those two manholes to generate the velocity that is needed. So what is the formula for the slope of the line? Well, it's slope in a percentage form. Slope is equal to the rise or the vertical difference between the two manholes, and then the run, which is the distance between the two manholes, and then multiplied by 100. So let's take a look. Now let's take a look at the following. Question. Two manholes are 145 meters apart, so that's stated. The top of one manhole is 2.8 meters higher than the other, and you're assuming that the distance from the top of each manhole to the bottom of each manhole is the same. What is the slope of the line connecting these two manholes? So now the first thing we look at, keywords. First thing is 145 meters apart. That's right in the first sentence. The next thing we look at is one manhole is 2.8 meters higher than the other. And the third thing that's important in this question is, well, what is it asking for? In this case, it's what's the slope of the line. And in this case, it will be in a percentage format. Now, the formula that we're going to use is slope equals rise, or the vertical distance between the two, and divided by the distance, the horizontal distance between the two. And then, of course, you have to multiply that by 100. So slope then is equal to, in this case, 2.8 meters divided by 145 meters. That's the distance apart. And your answer has to be multiplied by 100 because it's a percentage value. And in this case, the slope is equal to 1.93%. Now that's a fairly straightforward question. You're given the rise, you're given the run, you have to find slope. And that works out quite easily. But some people have some real challenges when you have to start manipulating this formula around. So I'm going to give you a little trick that you can use to make this a little bit easier. Now we're going to go back to the circle T or the pie chart. I'm not sure how. Now we're going to go back to using the pie method of solving. And in this method, notice slope is in the bottom right-hand corner. And it's equal to the one that's above it, which is rise. And then notice there's a dividing side, and there's a dividing sign in the pie, and the run is underneath it. And so as a result, the bottom right-hand corner slope is equal to the top rise divided by the run. And then we have to multiply by 100 because it's in a percentage format. So now, that's one way to do it. But what happens if you're not looking for the slope? What happens if you have the unknown is the run? Well, that goes in the bottom left-hand corner. And remember, that's equal to the rise, which is on top. It's above on the pie. And it's divided by the slope. And again, you have to make sure that this slope is in a decimal format. Okay, so that's a second variation of it. And as long as you know the locations of where these three variables are on the chart, it makes it a lot easier to work with. So now in this case, rise is in the bottom. Now in this case, rise is on the top, and again, it's equal to the run, which is in the bottom left-hand corner. Notice it's beside the slope, so you multiply those out, but you just have to remember that the slope has to be in a decimal format. Now let's take that pi method now let's take a look at that. Now let's use that pi method of solving in the above. Now let's use that pi method of solving in the above question. If a manhole A is 255 centimeters above manhole B and the slope connecting the two manholes is 70. If manhole A is 255 centimeters above manhole B and the slope connecting the two manholes is 0.75%, how many meters apart are the two manholes? Again, we always start off with keywords. In this case, 255 centimeter above, but you also have to remember that 255 centimeters is 2.55 meters. The slope is 0.75%, but remember it has to be in a decimal format, so that's 0.0075. You move the decimal 2 spots to the left. And how many meters apart is another important part. That's what we're looking for. That's the unknown. Which variation of the formula are we going to use? Well, we go back to the pi and remember that the rise is on top. And in this case, it's 255 centimeters or 2.55 meters. The slope is 0.0075. And notice we divide the rise by the slope to get the answer, which is how many meters apart, which is the run. So now let's put the numbers in. The run, we don't know what it is. The run is equal to the rise, which is 2.55 meters, so we'll put that in. Notice it's above, which means divided by the slope, but remember you have to put that slope in as a decimal number. And in this case, it's 0.0075, so we plug that in. And when we do the calculation, it works out to 340 meters. That's it for this video. Please pass this site on to anyone you know who may be struggling with various metric water and wastewater math questions. Also, feel free to leave some comments. Thanks for watching this video. Have a good day.